Hello everyone, my name is Sydney Kitable. Today we're going to be looking at what is a graph database. A graph database is not the same as a chart. It's very much different. The two different things. Graph database actually evolved from a graph theory, which is a mathematical concept of vertex and edges. It's actually been around for a very long time, but today with advancement in technology, we've now been able to use graph theory for information management. What's the definition of a graph database? It's a collection of nodes and relationships with properties. For example, you have two entities, one Microsoft, the other is LinkedIn. Microsoft has just recently acquired LinkedIn for over $20 billion. Now, if you look at it very carefully, there are nodes are the two entities, which are the companies, one Microsoft and the other LinkedIn. And the relationship is that Microsoft has just acquired LinkedIn. And the relationship there is acquired. Real-world applications using graphs. Graphs solve a lot of real-world problems. Recommendation systems are solved with graphs. Fraud detection analysis are handled by graphs. Network analysis are also handled by graphs. Master data management are also handled by graphs. And project management are also handled by graphs. So graphs are becoming more and more indispensable in real-world applications. Which companies are making use of graphs today? You have Facebook, LinkedIn, Google, YouTube, Amazon, and many other companies. These companies use graphs to optimize their resources and also deliver quality services to their customer base. It's hard to say that without graphs, they would have been very successful today. Graph database model. Now this is what you could term as a graph. You have three nodes. This is a node, and you have two relationships. Teams featured in matches, and referees officiated matches, or matches are officiated, or referees officiate matches. So what you can see, you have three nodes and two relationships in our graph database model. Today, we're going to be focusing primarily on Neo4j's technology as with relationship to graph database. There are other database technology, but we're focusing primarily on Neo4j. These are some of the essential features of Neo4j. It has labels, nodes, relationship, properties. Might I also add that the query language used in traversing the graphs within Neo4j is actually referred to as Cypher. Sometimes it's referred to as CQL, Cypher Query Language. It's used in querying database in Neo4j's platform. This is a database visualization of graphs within Neo4j. Here you can see the nodes and you can see the relationship. Osas Wellness likes Boston Legal. Osas Wellness dislikes Gotham. Baripote Wellness likes House of Cards. And Baripote likes Power. You can see very well that our nodes are connected by relationship, and that's all you need to know about it. That's the basic definition of a graph database. That their nodes connected by relationships. It's very easy. It's not very complicated. This is a graph showing the relationship between family members. Osas Wellness related as family. Baripoti Wellness related as family to Tari Wellness. You can see here we have 3 nodes and 2 relationships. This is a relationship. This is a relationship. And you have a node here. This is another node. We have another node here. Might I also add that these nodes can also have properties within them. And the relationship can also have properties within them. Now these are TV shows seen by Tari. She's seen Glee. Tari has seen Empire. Tari has seen Suits. Tari has seen The Flash. Now let's take a look at a real-world application of graphs towards solving the problem that we have listed written on the slide. Find a TV show mutually liked by 2 individuals with common ties to another individual who has not seen the TV show. This is a question which graphs can handle and solve. Now, we previously said that we had a challenge which we wanted to use the graphs to handle. The recommendation of a TV show with mutually exclusive ratings by individual with common ties to Tari. Now, the TV show as recommended by the graph to Tari is House of Cards, which has been seen by 2 of her family members with common ties to Tari. The TV show seen by both Baripoti and Osas with mutually exclusive ratings of the show. You can see that Baripoti likes Power and House of Cards, and Osas likes Power and House of Cards. And if you looked at the previous slide, you would see that the recommendation system recommended House of Cards to Tari as a TV show that she hasn't seen yet, but has been seen by 2 individuals who have common ties with her. Now I hope you have had a brief overview of what a graph database is. If you have any questions, if you have any feedback or any comment, please feel free to reach us on this following social media platforms available on the slide. And we thank you very much for making time out to watch the video. Thank you.